Welcome back to the Blackboard. We are still going to continue with the first order system lecture. And in this second example, we are given a first order system and we have to solve the system of a first order system. So let's get started. I accidentally wrote the question or the example wrong. But let's get started. So if you remember in lecture, we never really discussed how to actually solve first order systems, but I did mention that we can create a second order, or we can get a second order differential equation and convert it into a second dimensional linear system. So what we can do in this example is actually convert back to the second differential equation or second order, solve it, and then plug it in. So for the first example, I let it became a simple example. So we know that x prime is equal to y, and y prime is equal to x. And because x is equal to x, y prime is equal to x. Because x prime is equal to y, then that means y prime is actually equal to x double prime. And so what we can do now is we can substitute this in with the second equation, giving us x double prime equaling to x, or x double prime minus x is equal to 0. And so how do we solve this? Well, we can use this becomes a homogeneous differential equation with constant coefficients, so we can use the characteristic equation. And so when we do the characteristic equation, we will get r squared minus 1 is equal to 0. So this tells us that r is going to be equal to plus or minus 1. They are not positive, they are real roots. So our answer for x, so x of t, will be equaling to c1 e to the t plus c2 e to the negative t. So we pretty much kind of solved it, but we have to find the solution for the system of equation. So this tells us that we only found half our x, and we're just missing our y. So our y, well, our y, we know what our y is because y is equal to x prime. So what we have to do is take the derivative of our solution that we found, and we will get our answer. So when we do that, we will get c1 e to the t minus c2 e to the negative t. And so this will be our solution and our answer to this problem, and we can go ahead and move on to the next one. The next one, again, we have two equations, so it's going to be a second order. This time we have conditions. Whoa, conditions. So it's the same thing applies. You just find the equation and then solve it. Because it's going to be a second order, it's going to be homogeneous, and it's going to be, what's that word? With constant coefficients, we can use the characteristic equation. So x prime is equal to negative 2y. So this tells us that y is actually equal to negative x prime over 2, and y prime will be equaling to negative x double prime over 2. And so when we plug that in, we will get that x negative double prime over 2 is equaling to 2x. Do a little bit more of fiddling around with algebra, and we get the equation x double prime plus 4x is equaling to 0. So we have our second order differential equation. We can use the characteristic equation. So the characteristic equation will give us r squared plus 4 equal to 0. So right here, it can't be real solutions, it can't be repeated. So that means our solution is actually r is equaling to plus or minus 2i. because that will give us 4 times -1, so -4. Yeah. And so this gives us the case of complex roots, allowing our solution equaling C1, because a is 0, there's not going to be no e, so it's going to be times cosine of 2x plus C2 times sine of 2x. And again, this is only our half of the answer. The other one is plugging it in with this portion here. So our y, actually let me put x of t. Our y of t will be the derivative of x of t divided by -1/2. So this will give us negative times -2 c1 sine of 2x plus 2c2 cosine of 2x all over 2. Now what we can do is we can cancel out 2's, distribute the negative, giving us the equation c1 sine of 2x minus c2 cosine of 2x, and this gives us our solution to be x, y is going to be equaling to c1 cosine of 2x plus c2 sine of 2x, and then c1 sine of 2x minus c2 cosine of 2x. And that would be our solution to our system, and that would be it for this example. This was a relatively short video. Hopefully this was more than enough to actually help you understand the process. It's just playing around with the substitution and doing a little bit of algebra. After that, you just use the characteristic equation. It should be 99% of the time, and solve them. But yeah, thank you for watching this video, and I'll see you in the next one.